right now? No, you're okay. Okay. So anytime we're asked to calculate the empirical formula, you're going to have one of two situations. You're either going to be given the percentages of each element in the compound, or you're going to be given a different unit like grams of a particular element. And sometimes you might see it in moles. Okay. Now, percentages are the same thing as grams. So I can drop the percent sign and these become grams. Okay. Then what you're going to do is you're going to convert grams to moles. Okay. So I believe step number 1 is percent equals grams. Took care of that. Step number 2, convert grams to moles. And in parentheses, it says do not round to sig figs. That's really important. So we're going to take our 18.7 grams of lithium and 16.3 grams of carbon and 65.5 grams of oxygen, and we're going to divide by the molar mass of each substance. Is lithium 6.94, I believe? 6.94 grams per mole. Carbon is 12.01 grams per mole. And then oxygen is 16. Notice I am not dividing by 32 because this is oxygen that's in a chemical formula. It's not diatomic because it's not pure. Okay, so 18.7 divided by 6.94. What you want to do here is take this like 4 or 5 places beyond the decimal and do not round. Okay, carbon comes out to be 1.3572. And then your oxygen is 4.0937. Okay, now, at this point, we're going to step 3. Step 3 says divide by the smallest mole. Well, isn't the smallest mole this mole of carbon, 1.35? So divide everything by 1.3572. Okay, this is going to give you 1.91, and then you're going to get 3.0. Okay, at this point, if you're within 0.1 of a whole number, you can round to that whole number, and these are the subscripts in the empirical formula. 1.9 is 0.1 away from 2, so therefore you may round this to 2. Okay, if it was 1.8, you couldn't. If it was 2.1, you could round it to 2, okay? This is 1, so it stays. 3.0, it's fine, okay? So we have Li2C1O3. So these are the numbers of each different type of atom in my empirical formula. Okay, and it's the same steps every single time, so it gets a little redundant. Okay, do you want to try this on your own? Okay, try number 2, and let's see what you guys come up with. Okay, did you get to this point? Okay, and then your smallest mole is this 0.8. So you divided everything by it. Did you get CCl2F2?
Yes.
Generally, the order that they give these elements to you in the problem is the same order that you would write it in the chemical formula. Okay? Okay, so we're good. We don't need to do this one that starts with grams instead of percent. Okay?
What do we do if, like, when we divide by the lowest number, it gives you a number that's farther than 0.1?
Okay, so let's do that as an example. So if for some reason, let's say I ended up at 1.5 here instead of 1, then what you would do is, let's say this is 2 and that's 2 still, okay? you would have to multiply a 0.5 by 2 to get it within 0.1 of a whole number. So that means this would become 3. Then you would multiply this by 2, which would be 4. And then you multiply this by 2, which would be 4 as well. So you would multiply by the same whole number all the way across. Okay? Okay. All right, let's turn to the next page. The last page. Okay? Okay, now let's move on to calculating molecular formulas. And there are two different scenarios for this. I'm going to jump straight to the practice problems. There is a short problem and then there's the longer problem. I'm going to do the short problem first. So if you are given the molar mass of something and the empirical formula, and they say, hey, what's the molecular formula of this substance? What you're going to be doing is you're going to figure out what you have to multiply the molar mass by, or the empirical formula by, to get the molecular formula. What I mean by that is empirical formula is often abbreviated as EF, and molecular formula is often abbreviated as MF. So if I know that my empirical formula is CH2O, and I am trying to figure out what the molecular formula is, you multiply this empirical formula by a whole number to get to the molecular formula. So this molar mass that they give you, this is actually the molar mass of the molecular formula. It's there to help you figure out what you're multiplying by to get the final answer, okay? So what you have to do is calculate the molar mass of the empirical formula. And we're going to put that right here, okay? So this is going to be 12 for carbon. You've got 2 hydrogens, so that's 2, so there's 14. 14 plus 16 is going to be 30, so this comes out to be around 30 grams per mole. Okay? What do I multiply 30 by to get to 60? Yeah, 2. So that means you're going to multiply this by 2 to get your molecular formula. Okay? So this would become C2H4O2. That would be your answer. That's the short problem that pertains to calculating molecular formula. Okay? Okay. Let's take a look at number 2, and then number 3 is the long one. Okay? Number 2 gives you an empirical formula, and they want to know which of the following are possible molar masses of the empirical formula that we're looking for. So if the empirical formula is C3H4, and this molar mass is 3 times 12, which is around 36, plus 4, which is going to be 40. So this is about 40 grams per mole. If I'm looking for the molar masses that are possible for a molecular formula, they would have to be a multiple of 40, right? 40 times 2, 40 times 3, 40 times 4. So would 55 work? No, because I can't multiply 40 by a whole number to get to 55. 40 times 2 would be 80, so that works. 40 times 3 would be 120, so that works. 20's out, because we'd have to divide. Okay? Okay, now, the last type of problem that you're going to get for calculating molecular formula is where they don't give you the empirical formula. So in number 3, they give you stuff to calculate the empirical formula, so you have to do that first, and then you have to do what we did in number 1 after that. Okay? So let's do number 3, and then that should carry us just under break. All right, so here it says a small sample was analyzed. It contained 4.5 grams of carbon, 1.13 grams of hydrogen, and then 6 grams of oxygen. They tell us that the antifreeze's molar mass is 62, so that's the molar mass of the molecular formula. And they want us to calculate the molecular formula for antifreeze. Well, we first need to calculate the empirical formula. So step one will be to calculate the empirical formula, and we have to do it the long way. Okay, so 4.51 grams of carbon, 1.13 grams of hydrogen, 6.01 grams of oxygen. We're going to divide each one by its molar mass. Notice I am not dividing by diatomic molar masses, like I'm not multiplying the molar masses by 2, because these are all elements that are inside of a compound, okay? I do not round my moles. I take my moles 4 or 5 places beyond the decimal. After I do that, I can divide by the smallest mole, which would be my mole of carbon. So divide this by itself. This is 2.9. You are allowed to round that to 3 because it's 0.1 away. So my empirical formula is CH3O. They want us to determine the molecular formula. They gave us the molar mass of the molecular formula. It's 62. The molar mass of the empirical formula will be 12 plus 3 plus 16. So this is going to be, what, 31-ish? 31 times 2 is 62. So that means C2 C2H6O2 would be my molecular formula. Okay. Okay, I'm going to take a break early. All right. Why don't you guys go on break?